What if you could not only predict the future, but also get a crystal clear explanation of why that future is the most likely one? Well, a new AI model is doing exactly that, and it's completely changing the forecasting game. We're talking about the Temporal Fusion Transformer, and it gives us something we've never had before, 2020 hindsight for what's to come. All right, let's kick this off with a kind of weird question. Why is the top-tier AI forecaster like a perfectly organized professional kitchen? I know it sounds a little strange, but the answer really gets to the heart of how this new model, the Temporal Fusion Transformer, manages to tame just an incredible amount of complexity. And trust me, by the end of this, you'll see exactly what I mean. So to really get this, we have to start with the core challenge. Forecasting is, it's absolutely critical everywhere. Business, finance, healthcare, you name it. But here's the thing. The most powerful AI models, the classic transformers that totally revolutionized language, they were just never built for this job. They slam right into what everyone calls the black box problem. And here's why. Think about it. A language AI gets a really nice, clean, uniform input, just a sequence of words. Simple enough. But a forecasting AI, it gets handed a messy jumble of information. It's got to juggle data from the past, things we already know are gonna happen in the future, and static facts that never ever change. They are just fundamentally different beasts. This slide just lays it out perfectly. Forecasting models have to deal with three totally different kinds of data. You've got your static data, like a store's ID number or where it's located. Then there's the observed past data, think yesterday's sales numbers. And finally, you have known future data, like an upcoming public holiday or a big sale you've planned. Old models, they just kind of throw all this into a blender. It's like a chef who doesn't know the difference between salt, sugar, and chili powder. They can't tell what role each ingredient plays, and the result is a messy, unreliable forecast. And that leads to the second and honestly bigger problem. Even when these black box models magically get the right answer, they can't tell you how they did it. This lack of interpretability is a huge deal breaker. If you're about to make a multi-million-dollar decision based on a forecast, an answer of, just trust me from your AI is not going to cut it. But what if? What if a model was built from the ground up to solve these exact problems? Well, that's where our hero enters the story. Let's meet the Temporal Fusion Transformer, or TFT for short. It's a specialist, designed from day one for the messy, high-stakes world of forecasting. So what is this thing, really? The TFT is an attention-based architecture, sure, but unlike the ones that came before, its whole purpose is twofold. One, deliver insane accuracy, and two, provide clear, understandable insights into its own thinking. It's built to finally break that old trade-off where you had to choose between a model that was powerful or a model you could actually understand. The core promise of the TFT is pretty simple, but it's really ambitious. It's designed to seamlessly handle all those different types of data, to crack open its own black box and explain its reasoning, and to give you a range of likely outcomes, not just one single guess. And the amazing part? It does all of this while performing at the absolute cutting edge of accuracy. Okay, remember that kitchen question from the beginning? Let's go back to that. Because to see how the TFT pulls this off, we're going to go inside the model, using that analogy of a highly organized kitchen brigade. See, instead of one chaotic chef throwing everything into a pot and hoping for the best, the TFT has a whole team of specialists. Let's meet the team. First up, you've got the prep chef. This is variable selection. It's like a super meticulous sous chef checking every single data ingredient and tossing out anything that's noisy or irrelevant before it can mess up the final dish. Next, you've got the head chef, the static encoders. They read the master recipe card. That's your static data like store location to set the whole context for what's about to be cooked. Then, gating mechanisms act as the expert technique, intelligently deciding, hey, do we need a complex process here or will a simple one do? This prevents the model from overcomplicating things. And finally, my favorite part, the tasting spoon. This is the model's interpretable attention mechanism, and it tells you exactly which past events, which spices, are creating the final flavor of the forecast. It's incredible. So this whole organized kitchen thing sounds great on paper, right? But does it actually work? Well, let's look at the results. This is where we see that the TFT's approach doesn't just make for a cleaner process, it actually makes a better forecast, delivering amazing results in both performance and clarity. The numbers really do speak for themselves. Across a bunch of really tough, real-world data sets, we're talking everything from electricity demand to retail. TFT just consistently beat its competition. And what's most impressive is that it cut the error in the worst-case, most high-stakes scenarios by up to 9%. That is a massive leap in reliability right when you need it most. But like we've been saying, accuracy, as awesome as it is only half the story. The real breakthrough, the thing that makes the TFT a true game changer, is its ability to pop open that black box and show us why it's making the predictions it's making. So let's see what that actually looks like. This is so cool. This is where we literally get to peek inside the AI's mind. So when they gave it electricity demand data, the model, all on its own, learned the 24-hour daily cycle. Look at this graph. Those repeating spikes show the model paying intense attention to the exact same time period on previous days. It figured out that the best way to predict demand at 3 p.m. today is to look at what happened at 3 p.m. yesterday and the day before that. And this wasn't just a one-off thing. When they gave it retail sales data, it found a completely different pattern. Here, the spikes in attention are happening every 7 days. It learned the weekly rhythm of shopping, that what happened last Tuesday is super important for predicting what's going to happen this Tuesday. But this might be the most powerful example of all. The model doesn't just find these nice, regular patterns. It can spot huge, unscheduled shocks to the system. This graph shows financial data around the 2008 crisis. You can see the model's attention pattern completely changes, recognizing that the old rules don't apply anymore and a major shift is happening. It basically taught itself to ring the alarm bell during a crisis. So, what does all of this actually mean in the real world? Well, it all boils down to one simple but incredibly important word: trust. By showing its work, the TFT moves AI forecasting from being an opaque black box to a transparent glass box. And this is why it's so important. As the researchers themselves put it, people making big decisions need to understand the why to trust a forecast. They have to be able to check it against their own gut feeling, their own intuition. Explainability isn't just some neat tech feature. It is a fundamental requirement if these tools are ever going to be adopted in the real world. This table just makes it crystal clear. Your classic models give you the what, the prediction. They're a black box, and that leads to low trust and slow adoption. But the Temporal Fusion Transformer, it gives you both the what and the why. It's a glass box, and that transparency is what unlocks high trust and real, meaningful impact. So if you're going to walk away with just 3 things from all this, let it be these. Number 1, the TFT is just more accurate. It delivers better forecasts, period. Number 2, it's fully interpretable. It actually shows you the hidden patterns and the key reasons behind its predictions. And number 3, that combination makes it a fundamentally trustworthy tool, one that's actually ready for real-world, high-stakes decisions. This really is a massive leap forward. We're moving from an AI that just spits out answers to an AI that can actually join the conversation. And that leaves us with a really fascinating question to think about. Now that our models can finally explain the why, where on earth should we point them next?